Hey there, Seahawks, it's Miss Adams, and in this video, we're going to take a look at correlation coefficients. Alright, so a correlation coefficient is designated by the letter r, lowercase r, and it is a number in the range from -1 to +1, inclusive, that indicates how well a regression equation truly represents the data being examined. The strength of the relationship between the two variables is really what it's telling you. If r is close to 1 or -1, the model is considered a good fit. If r is close to 0, the model is not a good fit. If r is exactly 1 or exactly -1, the model is a perfect fit with all of the data points laying on the line. If r equals 0, exactly 0, then there is no linear relationship between the two variables. Okay, so when you are talking about the correlation, that is a mathematical value. Okay, so it comes with a number, and the number always has to be between -1 and 1. Can't be bigger than that. Can't be smaller than that. Okay, so it's some 0 point something usually. It can be positive. It can be negative. All right, and then the slope is always going to match the slope of your line. If you have a positive correlation, you're always going to have a positive slope. If you have a negative correlation, you're always going to have a negative slope. All right. A correlation greater than 0.8 is generally described as strong, whereas a correlation less than 0.5 is generally described as weak. And so then I just kind of gave you some scatter plots here of what a perfect negative correlation all the way through a perfect positive correlation and in between with no correlation. So the more close they are together, your dots, the stronger it is. The more spread out, the weaker it is. All right, so here is the actual formula for how correlation is calculated. And luckily for us, we have technology to do this with. So we are not going to have to use that formula unless you don't have that technology, in which case we will practice some the long way in class, but we are not going to do that right now. So how to find R in your calculator? So you're going to have your data, and you're going to go to Stat Edit, and you're going to put your data into your list, which you should be pretty comfortable with at this point. So Stat Edit, put your data into your list 1 and list 2, and then you're going to press Stat Calc, and you're going to do a linear regression. Okay, I would prefer that you use the linear regression option 8, so Stat Calc and then the number 8. Make sure that you're using the right list, so make sure that it's using list 1 for your X list, list 2 for your Y list, and then press Calculate. Okay, and you will get this little screen that has A, B, R, and R squared. Now, some of your calculators may not be showing you R and R squared, and you will need to turn the diagnostic on your calculator. And when you come into class, I will show you how to do that. So, but if you forget, it's just second and then the catalog button, which is 0, and then just hit D to take you into the diagnostic, into the D areas of all the options, and then scroll through until you see diagnostic on and hit enter twice, and you're good to go. All right, estimate the correlation coefficient. So I have two scatter plots, and we're just trying to get a rough estimate, okay, of what is the correlation. So in the first one, I can tell it's negative. I can tell it's not very weak because I can tell it's definitely going down. It's not super strong. It's not a perfect line. I know that the correlation actually is negative 0.79. So hopefully you guess somewhere in between negative 0.5 and negative 0.85, and that would be good. And then the other one, I can tell that it's positive, and I could tell it's a little bit stronger than the last one. The last one was about negative 0.8, so I think this one is closer to 0.9-ish, so the actual correlation is 0.94. Okay, you're probably not going to guess these perfectly. What these will most likely be on a test or quiz will be a matching, where you'll have a bunch of them and you match them, and you can kind of see which one's the strongest one will get the highest correlation, which one's the weakest gets closer to 0, your positives and your negatives, it won't be that bad. All right, this one, interpret the correlation coefficient. So I give you the correlation, and you have to tell me what would that look like. So 0.98, I can tell that that is a strong positive relationship between X and Y. So there's a strong positive relationship between X and Y. And it should be linear. If we're using correlation coefficients, it should be linear, but I left off the linear just because for some of the weaker ones, we don't necessarily know. And then the next one, it's negative 0.21, so there is a weak negative relationship between x and y. And then the next one, 0.65, I would say that's probably more of a moderately strong. So there is a moderately strong positive relationship. All right. Go Seahawks.